Welcome to the next episode of groundwater. In this episode, we deals with factors controlling groundwater occurrence. So, in the first episode, we talk about groundwater, various sources and all. So, in this episode, we are going in detail about the various factors controlling groundwater occurrence. The occurrence of groundwater is chiefly controlled by the following factors: climate, topography, properties of rock. It includes porosity and permeability. Porosity includes sorting and size of the grains, and also it includes shaping and packing of the grains. So, how the grains are sorted within the rock's surface and how the grains are shaped and how it is packed within the grains. So, this includes the porosity, and next one is the permeability. So, these are the various factors controlling the occurrence of groundwater. Coming to the climate. So, as you all know, climate is an important factor. So, in arid climate, groundwater occurs at great depth, but in humid region it occurs in shallow depth. So, as you know, in dry climatic regions, groundwater occur at a great depth, but in humid region it occurs at shallow depth. So, shallow depth is more easy to trap the groundwater. Second factor is topography. So, what is topography? Topography means the area where which the particular rocks are placed. So, when the surface is flat, water table remains almost parallel to the surface. So, water table we discussed about it in the last class. So, water table remains parallel to the surface in the flat surface. So, in the flat surface, water table always remains parallel. Humid region, the water table follows an undulated pattern. So, in some regions, if the topography is undulated, so water table also forms the same undulated pattern. Then comes to the properties of the rock. So, this groundwater is stored within the pore spaces of the rock. So, properties of the rock is an important factor controlling the groundwater occurrence. So, coming to the porosity. So, porosity is the percentage of volume of the rock that is open space. So, how much pore spaces are present in the rock? It is the porosity. So, this determines the amount of water that a rock can contain. So, how much porous is a rock? So, it contains as much water it can. So, the amount of pore spaces present within a rock refers to the porosity. So, porosity varies on the basis of the following factors. So, porosity is an important factor which controls the groundwater occurrence. So many factors depend upon the porosity. First one is sorting and size of the grain. Sorting and size of the grain means how the grains are sorted. So, sorting means you can sort a thing in various ways. So, you can well packed and well developed grains can be packed equally placed and all. So, sorting and size of the grain is first one, and shaping and package of the grain. So, what is the shape of a particular grain and how it is packed. So, it is the second factor. In sediments or sedimentary rocks, the porosity depends on so many factors like grain size. Second is the shape of the grain. Third one is the degree of sorting and degree of cementation. So, in sediments or in sedimentary rock, porosity depends upon 4 factors. First one, grain size. So, grain size means how much size the grain possesses. Then shape of the grain. So, each grain has different shape. So, second factor is the shape of the grain, and next is the degree of sorting. Degree of sorting in the sense how the grains are sorted. Is it well packed or is it poorly sorted, like that. That includes the degree of sorting. The next is degree of cementation. How the particular grains are cemented or joined within the rock. So, that is the degree of cementation. In this picture, you can see well rounded coarse grained sediments usually have higher porosity than fine grained sediments because grains do not fit together well. So, here in the picture you can see 2 figures. First one, well rounded coarse grained. So, well rounded coarse grain means the grains are too much size, usually have higher porosity. So, grains, if the grains are larger in size, it has higher porosity than fine grain sediments. In the next second part, the picture, you can see fine grain sediments. So, in the fine grain sediments, the pore spaces are very little. So, that means grains do not fit together well. So, well rounded and fine grain rocks, these are the two particulars. Coming to this picture, you can see it is poorly sorted. First picture is well rounded, well sorted. In this picture, it is poorly sorted. Poorly sorted means you can sort the grains in any way. So, just like packing things in a suitcase, you can pack things as you wish. So, you can well packed, and you can also pack things which is just putting it into the suitcase. So, here is the case of poorly sorted sediments. Usually have, poorly sorted sediments usually have lower porosity, because the fine grain segments tend to fill in the open spaces. So, within the gaps, what happens is fine grain sediments tend to fill within the gaps. So, poorly sorted sediments is having lower porosity, because the fine grain sediments tend to fill within the pore spaces, and the pore spaces are almost closed by the fine grain sediments. Then highly cemented sedimentary rocks. Next stage is highly cemented sedimentary rocks. Sedimentary rocks, actually it is so porous, but highly cemented sedimentary rocks have lower porosity. Why? Because cements tend to fill in the pore spaces. So, within the pore spaces, cement tends to fill, and the pore spaces is filled by the cement. So, the porosity is reduced. Coming to igneous and metamorphic rocks. So, you know igneous and metamorphic rocks are strong or durable rocks. In igneous and metamorphic rocks, porosity is usually low, because porosity is low in igneous and metamorphic rocks. Usually compared to sedimentary and igneous and metamorphic rocks, sedimentary rocks are more porous because they are loosely packed. So, in igneous and metamorphic rocks, porosity is low, because the minerals tend to be intergrown, leaving very little space. So, there is no free space within the mineral grains. That is why the porosity is very less in the case of igneous and metamorphic rock. But in the case of highly fractured rocks, if the igneous or metamorphic rocks are fractured, so these fractures rocks have high porosity, because due to the fractures there are chance to get the sediments to be intergrown, or there is chance for the grains to be cut across within the sediments. So, the fractured rocks having high porosity. Here is the range of porosity of some sedimentary materials. Materials are listed in one column and porosity is listed in another column. So, gravels, the particle size is bigger. So, the porosity is in between 25 to 40%, that is more porous. Then comes sand size particles, porosity is 30 to 50, it is also highly porous. Silt, particle size is again becoming lesser and lesser, porosity is 35 to 50. Then comes clay is having porosity 35 to 80, clay is highly porous. Then glacial till, it is having porosity of between 10 to 20%. So, this is the list of materials and their corresponding porosity. Coming to the rocks. So, some rocks, conglomerate, sandstone, shale, limestone, these are all sedimentary rocks. So, conglomerate is having porosity 10 to 30%, sandstone 20 to 30%, shale 0 to 30%, limestone again 0 to 20%. Next factor is the permeability. So, permeability means how water is allowing to pass through the rock. So, permeability is a measure of the degree to which pore spaces are interconnected and the size of the interconnections. So, how the pore spaces are connected, that is the permeability. So, how the pore spaces are connected within a rock, that is the permeability. So, low porosity usually result in low permeability. If the rock is low porous, permeability is also less, but high porosity does not necessarily imply high permeability. If a rock is highly porous, it does not imply that that rock is highly permeable. It is possible to have a higher porous rock with little or no interconnection between the pores. If the pore spaces are not at all interconnected, it is not permeable. A good example of rock with high porosity and low permeability is a vesicular volcanic rock. So, vesicular volcanic rock in the sense rocks with vesicles. So, what is the meaning of these vesicles? Vesicles are nothing but free or empty spaces within a rock. So, if there are so many vesicles present within a rock, so it is actually in volcanic rocks due to the expulsion of gases, there are so many gaps or vesicles present. So, rock with high porosity and low permeability, just like a vesicular rock, where the bubbles that once contain gas give the rock a high porosity. So, there are so many vesicles in the present, so it is porous, but since these holes are not interconnected, there are vesicles, but the vesicles are not at all interconnected. So, that is permits low permeability. So, good example for that type of rock is vesicular volcanic rock. According to the degree of availability, rocks are again subdivided into groups like permeable, semi-permeable, impervious. Permeable means usually gravels, sand, fissured sandstone, limestone, these are all permeable type rocks. Semi-permeable is sandy loams, loess, etc. Impervious means clay, shale, non-fissured, massive, crystalline and cemented sedimentary rocks. So, next is the water table. Water table we discussed in the earlier class, it is the top of the saturated zone, that is the water table. Water table can occur everywhere beneath the earth's surface. In desert region normally it is present, but rarely intersects the surface. In low places, water table may intersect the ground, forming certain swamps or marshes. So, in more humid region, it reaches the surface at streams or lakes and generally tends to follow the surface topography. The depth of the water table may change, however, the amount of water flowing into and out of the saturated zone changes. During dry seasons, depth of the water table increases. During wet seasons, depth of the water table decreases. This is a schematic representation of zone of aeration, zone of saturation and the types of water present within it. So, this is the water table, this is a undulated topography. So, the water table is also an undulated one. You can see river or lakes in one side, and if you dig a well in this position, the water table remains almost straight, but in the case of the river or lake exposed surface, water table is another position. Coming to the cone of depression. So, cone of depression, when excess quantities of water are removed from a well by pumping, ultimately the water table surface will lowered in the shape of an inverted cone. It is called the cone of depression. So, when we pump excess water from a well, so the water table is actually in a straight position. So, when we pump the excess water from a well, ultimately the water table surface will lowered in the shape of an inverted cone. Instead of straight line, the water table forms a shape of an inverted cone, and this is called cone of depression. So, in this picture you can see it's the original water table is in the first side, and the cone of depression is a depressed cone you can see. So, due to excess pumping from a well, the water table is positioned in a lower side just like a depressed cone. So, this is the cone of depression. This is also another schematic representation in which water table is lowered due to excess pumping from a well. Another feature present is perched water table. So, in certain regions where a lens-shaped body of impervious rock with a upper concave surface may hold a body of water above the permanent water table and may act as a local water table. It is known as perched water table. So, this perched water table is not a real water table. It is always present within the zone of aeration. So, zone of aeration actually it is in the zone of aeration most of the pore spaces are filled with air. So, if by chance if an impervious rock layer happens to be formed in the zone of layer, in the zone of accumulation, sometimes water will be present there. So, water table that is positioned above the normal water table for an area because of the pressure of an presence of an impermeable rock layer, it is known as perched water table. So, water table that is present above the main water table. So, this perched water table is not a real water table, it is placed above the main water table. Here sometimes there is a chance for impervious material to be happened within the zone of aeration. So, this act like a water body. Actually, it is not a permanent source for the water, but in some case by accidental case an impervious material happens to be present within the zone of aeration and it acts like a water body. So, this type of temporary source for water table is known as perched water table. Here it is also, you can see a perched water table, unconfined aquifer is present in the lower position, confined aquifer is present in the upper position, water table is present within the central region. So, this also you can see 2 layers, springs is coming up, springs arise from the point. So, spring is the point where water table intersects at the top surface. When the surface intersects with the water table intersects with the surface, it acts like a spring, water body. So, water just starts coming from the water table, just like seepages and all. So, we can look back once again to the various factors controlling the groundwater occurrence: climate, topography, properties of rock. It includes porosity and permeability. Climate refers to the climate. So, in the dry climate, you know, the condition is very dry, the water table occur usually at great depth, but in humid region it occurs at shallow depth. Topography, when the surface is flat, water table is also parallel to the surface. If it is undulating, the water table also possesses an undulated pattern. Properties of rock, regarding the properties, porosity and permeability are the 2 characters. Porosity refers to the amount of pore spaces present within a rock. How much amount of pores are present within a rock, that refers to the porosity. So, porosity is the percentage of pore spaces present within the rock, and porosity again depends upon how the grains are sorted and how the grains are shaped. Sorting and size of the grain and shaping and packing of the grains. How the grains are sorted and how the grains are packed. So, these are the 2 factors which depends upon the porosity. And again coming to the grain size, in the sedimentary rocks, grain size, shape of the grain, degree of sorting, degree of cementation, these are the important factors. And if the grains are well rounded and coarse grains, it has high porosity, but fine grained grains do not have higher porosity. Poorly sorted sediments also possess less porosity. Highly cemented sediments also possess less porosity. Permeability means how much water it allows to pass through a rock. So, when a rock is easily allowing the water to pass through it, that refers to the permeability. It is the measure of the degree to which the pore spaces are interconnected. So, how the pore spaces are interconnected, that refers to the permeability. Low porosity usually results in low permeability. Then coming to the water table, water bearing formations, you have cone of depressions. That is when excess water, quantity of water is removed from a well. Actually, the water table is in a horizontal line. So, when excess water is pumped from a well, the water table assumes to the shape of a depressed cone. So, that type of depression or that type of water table is known as cone of depression. So, the water table assumes the position of a depressed cone. This happens when we pump water excessively from a well. So, that is cone of depression. Then comes to the perched water table. Perched water table is the water table that is present within the zone of aeration. So, zone of aeration is mainly for air to be present. So, in most of the pore spaces are filled with air. So, it is not like a permanent water bearing formation. So, perched water table is a temporary water table that is present within the zone of aeration. So, how much water is present within that layer? Once the water is over, then no more water is present within the purged water table. So, purged water table is a temporary water table seen within the zone of aeration. It is an impervious material. Once the water trapped is over, that permanent water is not present there. So, it is a purged water body. Let me conclude the topic just now here. I hope you understood all the topics discussed here. Our next topic is about water bearing formations. Till then, bye.